Welcome to Inverclyde's training session today on fractions, decimals and percentages part 1. I'll do my best to give you some practical ideas to improve understanding of fractions for our pupils. This is a two-part course, so the first session will focus on fractions and part 2 will look at decimals and percentages. Let's make it quite interactive. I've taken this from White Rose Maths Bar Member Challenges just from last year, and it's a fraction problem at second level. So if you pause the video here, read carefully through the question and maybe have a think about how you might solve that problem and come back when you are ready. I'm not going to go over the answers for that just now, but what I'd be interested in is how being faced with this problem made you feel. Did you have a growth mindset? Did you see it as a challenge, determined to work on it and willing to give it a try? Or did you have a fixed mindset? Thought, do you know, I've never been that great at fractions. Did you give up? Did you think, oh, wait a minute, this is just too difficult for this time of day? Because quite often fractions are one of those concepts that adults find very, very tricky. And we then try it, not meaningfully, but we then put that on to the children in front of us. They also find fractions difficult. So hopefully today we're going to find a way or some ways to help them overcome that fear of fractions. So as we go through the session today, there are just a few points that you might want to reflect on as we progress and maybe consider and come back to it before part 2. So does our own confidence and knowledge of fractions have an impact when we're teaching fractions, decimals and percentages? Our experiences from when we were taught fractions, how does it affect what we think about them now and how we teach them? Are we confident in using a range of methods to teach fractions for understanding, or do we tend to go back to the same kind of similar processes all the time? And do we have that positive mindset when introducing fractions, decimal fractions and percentages? So as we go through, just bear those in the back of your mind, and maybe before the next session, you'll have thought about them more deeply. If you were like me, you were taught the process of how to carry out different concepts. Phrases like what you do to the top, you do to the bottom, divide by the denominator, multiply by the numerator, divide by 100, then multiply by the number, find the common denominator. And did the way we were taught help us to actually understand fractions, decimals and percentages? I know it didn't really help for me. Too often we were taught a process without having an understanding, and fractions is still a concept that many adults fear. We want to change that, and in order to do so, we need to make sure our pupils have enough experience of fractions in a variety of formats using concrete and pictorial representations before moving on to these abstract concepts. So why are fractions difficult? Well, fractions are a number within themselves, and they have their own place on a number line, but it's also part of a whole. They have many meanings, parts and operations, and they're really uniquely written. So we can see this as 3/4, but it has absolutely no relevance to the whole number of 3 and the whole number of 4. They're very different from whole numbers. For example, a half can be thought of as being greater than a third. But if we look at this picture and we have two different sizes of pizza, it's relevant to the whole whether a half is greater than a third, which makes it very confusing. And 6 divided by a half, they don't think about the same operation as we've used, because 6 divided by a half is actually 12. So they don't conform to our usual way of thinking of how to deal with division. Equivalence, we could have the same fraction and different names for them, yet they do have that same value. This infographic is showing how well pupils performed in different concepts of numeracy and maths in the year 2019. And it was written by the SNSA. This one's for primary 4. And if you can see, I've highlighted the fractions, decimals and percentages organiser. And if we look over at the right hand side where the green and the brown bands are, it takes up about 40%, and that's really telling us that 40% of pupils in primary 4 are performing well with fractions. It still leaves us with nearly 2/3 of the class not having that understanding, with nearly a quarter of them underachieving. By primary 7, only 35% of pupils are achieving in the highest two bands, and almost 30% are underachieving. That's more than in primary 4 for fractions, decimals, and percentages. And it actually is a bigger percentage compared to the other organisers who are underachieving. The data shows that by S3, about 25% of pupils are performing well in the highest two bands for fractions, decimals, and percentages. But by S3, the complexity of fraction concepts does increase, and around a quarter, although that quarter were performing well, there's a bigger percentage in the middle bands and at 20% of children who are not performing well in those last two bands. If we compare our children's performance in relation to SIMD, we can see the gap is significantly wider between those in areas of high deprivation, 1 to 4, and those in the higher SIMD Vigentiles, 17 to 20. So if we look at primary 1, on the left-hand side of the screen, we can see that there are more children in SIMD 1 to 4 who are not performing well in fractions, decimals, percentages compared to those in SIMD 17 to 20. They've got a really, really narrow blue section. But if we look at those who are performing well, the top line in primary 1, the green line, is showing those who are performing well in SIMD 1 to 4, the second line from 5 to 16, and the third green line from 17 to 20. So we can see that there are more pupils in the bracket 17 to 20 performing really well than there are of those children in the lowest SIMD brackets. And this is the same for numeracy overall. The same applies for primary 4, then into primary 7, and then into S3. And each time that gap seems to be getting bigger and bigger and bigger. And this is what's concerning for us. So we really want to adapt our teaching to try and narrow that attainment gap in fractions and decimals, percentages, and of course in numeracy overall. So you might want to pause the video here for a few minutes just to reflect on that data. Do the findings in the report reflect what is happening in our classrooms? Do you notice a significant gap? How might we plan for appropriate challenge and development of reasoning and problem-solving skills, particularly for our children who are in the lower ends of the SIMD Vigentiles? How do we best support those children in the lowest SIMD too? These are some of the questions that you might want to have a little think about, and feel free to pause the video to do that. I'm just going to signpost you to a couple of documents which will support you in the learning and teaching of fractions. The one at the top there, the fractions, decimals and percentages PLR, is a great resource. It's got lots of really practical advice for you. It's a real good, easy read in the suite of resources. And it'll give you lots of tips on how to teach fractions using concrete, pictorial and abstract. So I've got the link to that there, and I've also got the QR code for you to follow. And if you go into the Education Scotland National Improvement Hub too, then you'll get lots of really good advice. So just another little bit of interaction then, to pause the video here and either have some pieces of paper or even just draw some squares. It's how many ways can you fold a piece of paper into 4 equal parts, or to draw it into and make it into quarters. So pause the video and come back when you've done that. So when introducing fractions, maybe we should be doing more types of activity like that, giving a blank square and asking pupils to fold it into 4 equal parts. It's better than giving people shapes that have already been split into quarters for them. And folding gives them a much richer understanding because there's lots of ways to fold. And it'll also help later on when children come to representing fractions on their fraction wall. So traditionally, we might have, and this is how you might have recorded your quarters, and we teach these, without thinking. They're quite straightforward. So I'm sure that you got many of those ways of how to fold or draw quarters on your page. But if we have a look at these ones are a little bit deeper. And having pupils model the language of fractions and getting them used to the correct terminology will lead to that deeper understanding and finding out, are these ones still split into quarters, particularly the ones that are different shapes, because away down maybe in primary one, they've always been told, it's 4 equal parts that of the same size and the same shape, but that's not necessarily the case. So we don't want to teach that misconception. It's really important to allow pupils to discuss that and to investigate it in this way, either through the paper folding or by drawing too, and looking for examples and non-examples so that they don't get that fixed idea of what a fraction is. So I'm just wondering if anybody did draw something along those lines, or perhaps even this way too, when it's not actually quarters, but it's 2/8, and then we can bring in that idea of equivalence. The talking about number folder that has a flip chart in it, and it's dedicated to fractions, decimals and percentages, has some really good examples of this that we'll look at later on. Using concrete materials is really important for fractions, and it's one that we don't want to move away too quickly from and move on to the abstract. So how many of these manipulatives have you used to teach fractions? There's 15 suggestions here, and there might be ones that again you go to on a regular basis, and there might be some new ones that you might want to try out. And again, if we were face to face, we would take the time to discuss in groups the different concepts that they might be used for and how they support that greater understanding and eliminate misconceptions. But this is something that you might want to take away and consider. And again, using a variety of manipulatives is really important rather than sticking to just one or two types only. And if you can think of something else that you use to teach fractions, then get in touch and I can add it on for the next time. It's great to share ideas. And if you've got anything that you've been doing along the lines of this, again, the Sharing Good Practice channel on the CMO training team is a great place for that collegiality aspect. So we can see here lots of different ones, interlocking cubes to paper strips to even a ruler, and seeing how that's been sectioned off. We're lucky in Inverclyde, we've also got the rainbow fractions that we'll look at here that I haven't even included. But the pattern blocks is a great one as well, and the double-sided counters and geo blocks too. So the rainbow fractions kits were bought for all the schools in Inverclyde, and they contain a variety of fraction models to help students understand fractional concepts and skills. There is a teacher's book which goes along with it, and there's lots of activities within that that you can use and try, and photocopiable sheets that you can print off. Although the fraction models, that's the circles and the squares and the tiles and the towers, deal with the same concepts and skills, it's really important for students to experience a different visual perspective for fractional parts, how they're named and compared and operated upon. And this really helps them to generalise and transfer their knowledge about fractions. Um, if I come out to model fractions, this is usually what I would bring with me, because I know that they're readily available in schools. Ideally, again, if we were face to face, you would have a lot of time to look at these resources, including the activity cards, and see how you might want to use them and try them out. So the rainbow fraction tiles can be built up in a wall like this one, or the circles can be used, and they're ideal for teaching equivalence and for comparing fractions. So one of the activities you might do is an investigation task where they have to find out, which is bigger. And it doesn't matter if they've got the tiles or the circles or the squares or the towers, they'll still be able to work on those concepts. Um, and then report back on them so that they're having that opportunity to explain their thinking. During COVID restrictions, it may not be possible to share equipment, so an alternative is to use a virtual version from sites such as mathspot.com or Toy Theatre, and then you can bring up, they've got loads and loads of different ones, but you can focus in on the fractions or the decimals or the percentages one and use those, and get children to come up to the screen, or even if it is just visually, that they can see it from there. This is a great task. It's a low floor, high ceiling task, allowing for that differentiation. So if you pause the video here and just draw a wee picture of the envelope as I see it, and write 3/4 in the middle, and then your job is to try and think of different representations in pictorial format or even abstract that you could include in there. And then once you've done that, you can come back and we'll have a look at the different representations there might be. So what about your multiple representations? Did you draw representations of physical objects, like an area model, for example, 3/4 of a cake? Or maybe the set model, where you've got 4 packets of crisps here, and you've got 3 out of the 4 a different flavour. Or maybe the linear model, where here we've used Cuisenaire rods to show 3/4. And again, another one on a scale that you could use, a linear model that's issued like this. So it's indicating 750 grams, which is 3/4 of a kilogram, or in a kettle, which is 3/4 full. So these are some of the picture formats of concrete things that you might have drawn pictures of, and it's really useful to think about the area, set and linear models for fractions of a whole or fractions of amount, and even equivalence when you're doing that. But maybe you went down the pictorial representation route, and again we've got our area model here and our set model and our linear model, and we can see that really what we've done is we've indicated 3 out of 4 squares coloured, which are part of a whole thing, whole square, and then we've got 3 out of 4 circles coloured, and we've got 3/4 on the number line to show it on the linear model there. And if we model these, children will become more familiar and their confidence will increase in seeing fractions in a variety of ways. I've purchased the numeracy blueprint boards, and they're a great way of working with fractions pictorially before moving on to the abstract, and these should be getting used at second level when we are back at school. First level have had the opportunity to pilot them, so if you're at second level, I would be asking for a shot of the numeracy blueprint boards. So if we're going to demonstrate fractions on it, I might begin by asking the children to draw a 4x5 grid, for example. So we've got 5 rows of 4, or 4 columns of 5. And I would ask the question, how many little boxes can you see within this shape? And again, I would be modelling this, and obviously they'd be able to tell me that it was 20. And how many rows are there? So I've got 1, 2, 3, 4, 5. I've got 5 rows in there, and that makes each row 1/5 of the entire shape. And if I'm thinking about how many are in each row, we can now clearly see there are 4 in each row. So the value at the moment for each one of those circles is 1/20th. So at the moment I'm seeing 4/20ths, but because that's the same as 1/5, because it's in one row. So we know that one row is a fifth, or we could say it is 4/20ths. If we have 2 rows filled, then we would have 2/5ths, or we could also say the equivalence of that is 8/20ths. And we can continue with this pattern for 3/5ths and 4/5ths and 5/5ths, and then obviously that's representing a whole. at the end, or 20/20ths. Using the part whole model is a really useful tool to have when you're trying to teach fractions of an amount using the pictorial format rather than jumping straight to the abstract. So for the part whole, students need to understand the parts in which the whole is partitioned. They need to be of an equal size. The parts when you're taking them together must be equal to the whole, and the more parts the whole is divided into, the smaller the parts become. The relationship between the parts and the whole it remains the same regardless of the size, shape, or orientation of the equivalent part. So you want to maybe delve a wee bit deeper into this, you could start off with using concrete materials such as Cuisenaire rods. But if you refer to sites like the Count on Us, Thinking Blocks, White Rose Maths, and Enrich for further reading, it'll help you to develop skills within this. The Singapore Math primary curriculum is another really useful site to go to as well, because that's where it kind of all stemmed from. So do a wee bit further reading on that. So if we look here, we can see we've got a whole model that's been split into 3 equal parts. 2 parts of it have been shaded blue and 1 part has been shaded in purple. And then if we say, for our example, what is 40 divided by 5? Then I would be looking to make a whole model, split it up into 5 equal parts, and then indicate the whole model and where 1 of the fifths would be, so that I can see that. So I can see that this little section down here is worth 1/5. Therefore, 40 divided by 5, I would want to slot in 8 into each of those empty spaces to show what the value of each of the parts are. So here's a little problem put into a context. Matthew has a 300-gram block of cheese and he eats 2/5 of the cheese and he puts the rest back into the fridge. How much cheese did Matthew put back into the fridge? So we want to know the quantity of the cheese, not just the fraction of the cheese. So we've got our model and we know that the whole block is worth 300 grams. And because he eats 2/5, we want to split that block into 5 equal parts. Then we can indicate the 2/5 that he does eat, and we can do that by colour as well. And the rest of it is what he's going to put back, and that's what we're trying to figure out. So we can see he eats 2/5, and we can see he puts back 3/5. So what we need to find out now is what is the value of each one of those blocks, each one of them, and then it's really useful at the side to have your calculations. So we've got 300 and we're dividing it by 5, which gives us 60. And that means we can put 60 into each one of the blocks. And we can then see that there are 60 and 60 and 60 that he puts back. So 3 sets of 60 gives us 180. So we can see that he puts back 180 grams worth of cheese into the fridge. And we can also see that he eats 120 grams of the cheese. So this is really useful for talking through a problem and getting children to explain their thinking. Here are the links to the different websites that I've made reference to in today's presentation that you might want to delve a little bit deeper into. So once the video has finished, you can rewind it and get to these links, or pause the video now and make a note of them. Again, I think it's time for a little brain break, so we're going to pause the video here. We're going to look at the block here that we have in front of us, and you're just going to see what you notice. So pause the video, have a wee think, have a wee move around, and come back when you're ready. These were taken from fractiontalks.com, and it's quite open-ended, but you can also look at the site mathforlove.com, where you'll get lots of fraction talks too. As in number talks, talking about fractions, it's really important for children to get the opportunity to explain their thinking. So within the Talking About Number folder that's on Staff Shared, you'll be able to access the Fraction Talk flip charts, and these guide you through lots of different concepts. So for example, here you can see the first one, which is a first into second level. It's looking at the fraction of an amount, and it always asks a question. For example, in this one, which of these models represents an eighth of the whole, and how do you know that? So we're wanting
So that
pupils to
brings
be
us
able
to
to
the
look,
end of our
even if they're
first
not all
part of the
exactly the
fractions,
same
decimals and
shape as each
percentages
other,
course with
that
our
they can
focus
still
on
indicate
fractions.
which ones have
We
been
remember
split
the
up
aim
into
for today was
eighths.
to explore some
So
practical
that's really
ways to
a
ensure
really
the
useful one
understanding
to
and
have, and
progression
obviously which
of
ones are not split
fractions.
up into eighths as
And
well.
next time we'll look at
The
decimals and
second one is,
percentages
can you
in the
see
same
something
contexts.
in a different way,
If you wouldn't
and how
mind
can you
going
prove your
and filling
thinking?
in the
So this slide
evaluation,
here is thinking about
just
sixths,
again, it
and
helps us
how
think about
we
what
would
needs to
represent a
change about the
sixth
course
in each of those
and
different
adapt it for
shapes
the
there.
future.
So we would
And it
only be
also
shading
lets
in
you
one
think about
part of the first
how you want to take it
shape,
forward and the
and then in the
impact that it's
second
had
shape we can
on your
see one
practice
sixth
and what
as
you
being the
intend to
same
do
as
with it.
2/12ths.
Don't forget
And
to get
what
in
I would
touch
do
with
is I
me
would hide the actual
either by
results and
email
ask the
or
pupils to come
through
out and actually
tweeting
colour
at
in, with the paint pot or
INGIC478
with the pen tool,
or at
to show me how
InterCollege
a
And
sixth would
whenever
be
you're tweeting
represented in each
anything
of the
about
different
numeracy and
grids.
maths,
And then
to
we'll
include
be
the
looking at their
hashtag
equivalents, because there's always another way
INVNUN.
to
It
see it.
works
So we
really,
can
really
say
well
a
during
sixth
Maths
of
Week
the whole,
Scotland,
but one
but we
sixth is
want to make
also
sure
equal to
that
two
that is
twelfths,
happening
and then
throughout
further
the
on it's
year
also
too.
equal to 3
So thanks
eighteenths
again
and
for attending
4/24ths
today,
and so
and I'll
forth,
see you for session
so on
two.
and so forth. The next one is thinking about